Hi and welcome to Game Creation, and today we're going to be doing some really advanced stuff. I'm going to make it as simple as possible, but with missile command we've got the missiles coming from the top and we've got our bases at the bottom, and the position of the missiles is going to be random, and we need a way of figuring out how to get this thing down here in a nice smooth line. And we actually use some quite advanced maths for it. And if you remember doing trigonometry at school, that's going to be useful. But actually, the way that programming languages, including Clickteam, deal with this is they give us a beautiful function, and it's a really, really nice thing. So if you're worried about this being too advanced, don't be. We've got probably going to have about 5 or 6 lines of code, and that's it. So it should be really, really simple. And it's one of those things that maybe when you need this, you just look this up and just copy what's there, and it will do what you want it to do. So we're not going to be using the project we started last time because I was just thinking about it, and I think there's just too many things on that screen for us to really focus on what we want to do. So I'm just going to start a new project just for today to show you the basics, and then we'll incorporate it into the project in tomorrow's video. So let's get started. So I've set up a brand new project, and all I'm going to do is create 2 actives, and this will be the moving active, and this will be the target active. Simple as that. So all I want to do is have this one move towards that one, which sounds quite simple. Wow, that is a really poor spelling of target. Let's try that again. It sounds really simple. It's not simple, and then it is simple. It's not simple because if you're just sitting there with like Clickteam and no other resources, unless you know a lot about maths, you're going to find it difficult. However, you've got me, and I can show you how to do it. And well done if you know how to do this anyway. I think this is something that if you are ever going to be working in like actual, hardcore games or any kind of games really, this is something you should have up your sleeve. Okay, so what we're going to do is we're going to, at the start of the frame, we're going to have a alterable value to set the x and the y positions of our player object, of our moving object. Now this is because we're going to be working with decimals a lot, and the normal position of the normal positions only hold integers, and so we need a way of storing it as a decimal. Wow, that's really poor. What am I doing? The y position. This is a good start. So we've got the alterable value of the player object or the moving object holding the x and y coordinates. So we're going to be using that to do all the calculations of where the x and the y should be, because as I said, that will store it as a decimal, or a float we call it in computing, but it's just a decimal. Okay, next we're going to say every 100th of a second, because we want the animation to be smooth, we're going to first of all calculate the angle that this needs to be. So if I go back here, so we've got our moving object there and our target there. So we need to work out the angle that the target is away from the moving. So say if, the right hand side is 0, then you can see that would be like minus 45 degrees roughly, somewhere around there. Okay, I forget which. I think it's 0 to the right, and then you go positive going anti or counterclockwise. I call it anti-clockwise. Most people call it counterclockwise across the world, and then it's negative if it goes clockwise, and it will be minus 180. Whichever way around it is, and minus 180, 180, minus 180. Anyway, that's not important. You don't need to know any of that, because the function, and this is where Clickteam comes into its own. So what I'm going to do actually, I'm just going to create an alterable value, and I'm going to call it angle. Can't use that. The angle. using protected words. Anyway, so we call it the angle, okay? And we're going to set it here. So ultra value set the angle. Okay, now this normally was going to be quite complicated trigonometry, but Clickteam is nice. We like Clickteam because it sorts it all out for us. And Clickteam's not the only one. This is quite common for computer programming to have this arctan2 function, which isn't called that. It's called arctan of y over x. The reason it's called arctan2, well, first of all, arctan in the UK, and actually we do call it arctan, but I'm used to it being called inverse tan. It basically means the same thing, and that's the opposite of tan. So that's what that bit is. It's the opposite of tan. If you don't know what tan is, I'm not going to do a video about how tan is, or what tan is, but tan is cool. It's short for tangent. It's one of the trigonometric ratios, sine, cos, and tan, or sine, cosine, and tangent. And it's all to do with right angle triangles. Anyway, the 2 here says that it actually takes 2 parameters, which is unusual because sine, cos, and tan normally only take 1 parameter. It needs the y and the x. Now, the reason it's the y and the x, and you might think, well, hang on, I remember in school it used to be the x and the y, but it's the y then the x. And if you think about gradients and stuff, it's always y over x, and there's often times where y comes before x. Anyway, I'm rambling. So what's this mean? Well, it means it wants to know a distance of the y's. And so you get your target y first, and it has to be the target first. That's what it's expecting. What am I doing? So position of the y coordinate, and we take away the position of the y coordinate of the one we want to move. Okay, so it's target, take away the moving one. Okay, copy that because it will be exactly the same over here. X and X. Okay, click OK. Now I can try that now. It's not going to be moving because it's just working at the angle, but I can look into the alterable value. We can see the angle is 47, so it is positive going down. I don't know what I was talking about. So I said it would be about 45 degrees, and it's 47 degrees. Let's move it a bit. So if I move it up here, hopefully it will be less. You never know. There we are, 26 degrees. That's what we're expecting. And if I move it below down here, I'd expect it to be just over 90 degrees because I think I overshot that. Yeah, 90.23. Perfect. So we've got our angle in, is it Cartesian? Yeah. In degrees. In degrees. Okay, cool. Right, so we've got that. Now, that's useless to us. Okay, that doesn't do anything for us. We just need that for this next step. Now, this next step, we work out the distance that we're going to cover. Okay, so we are going to set the x value, and we're going to get the old x value. So we're just talking about the alterable values here. Okay, and we're going to add the cos of the angle. Okay, and you can get cos here, or you can go into here and get cos there, or you can just, it's just easier to type cos. They have a capital C, I think, on their one. I don't think it matters at all. And we're going to get the cosine of the angle. Simple as that. Okay, I'm going to copy that because we're going to do exactly the same thing for the y. Though this time it's going to be the y bit there. Now, it's not going to be cos anymore, it's just going to be sine. Okay, so you cos the x and sine the y. Some people say take away here, but we're on computers, so we've talked about it so many times that up is down and down is up. So plus means down and take away means up. Okay, that's just a computer thing. Last thing we're going to do is just literally put the positions in place. So select the x coordinate, which will be the alterable value x. I'm just going to copy that so that I can set the y coordinate, wherever we are. So position, Y coordinate, and we're just updating it. So essentially we're using this alterable value X and Y to represent the angle, but it will still work if you don't use the alterable value X and Y and just do it straight to the position. But you end up, so say if this is my target and my mouse is the moving object, you end up with it going like this, getting in line with it and then going up. It creates kind of jagged kind of lines. It doesn't create a nice straight line. Okay, let's see if this works. How nice is that? Perfect. Now I'm going to add a little bit more to test it works in all 4 quadrants, because one of the downsides of the previous way of doing this, before ATAN 2 was introduced to Clickteam, which I have no idea when, because for me it's always been there, but is that it would only work in the right hand 2 quadrants, and it wouldn't work going left, and you have real problems. You've got to create a horrible formula, which I say horrible, it's not that awful, but it's a lot longer than just this simple bit here. And this will show up on all sorts of websites, like for any kind of programming language, this line here. And the beautiful thing is they all call it ATAN 2, so it's nice and simple. And this bit here will show up the cos that and sine that. So what I'm going to do is just change the position of this randomly. And you know that I like to do it to specify what my minimum and maximum is. I think it's 480 by 640, but I'm not 100% sure. I think it is. Let's have a look what the standard one, 640 by 480. Obviously this needs to be 640. Okay, so I'm just going to, this line here is completely unnecessary, just randomise it so we can just test it under a whole load of circumstances. So it works fine there, works fine there, beautiful, like straight line, very, very nice. Okay, what if you want to change the speed of it? So let's go into my moving thing, create another alterable value called speed. Oh my goodness, keep getting pinged for that. The speed, right, I'm going to set it at 2. Now all you need to do for the speed, dead simple, is you just kind of accelerate this bit. So we're going to get this bit here, will tell us how much we're moving, and we just double it. So we times it by the speed. It's that simple. So we're just timesing that end bit by the speed. If you want to be explicit, you can put this all in brackets and say, I want to times this bit by the speed, because we don't want to times this bit. This bit here is the current x position. We don't want to times that by 2. But if you remember BIDMAS or BODMAS or order of operations, times will always happen before a plus anyway. But I like to be clean with the code and put things in brackets to say, yep, this is definitely happening first. It's completely unnecessary. Let's just change the sign. S-I-N-E, or S-I-N. Okay, let's have a look now. So it should be twice as quick. Oh, very quick. And by storing it as a variable, you can actually just change it throughout the game, because part of missile command is it gets quicker and quicker. And so, yeah. And so it really doesn't care where it is. And when it gets to the middle, it shakes a little bit because it's doing rounding. This is part of the problem, is that it will round. So you'll never get a perfectly straight one. But then again, if you think about the fact that there's pixels there, and so it has to get towards the nearest pixel anyway as it goes up. So it's never going to go completely straight. You don't get straight lines on computers, or straight diagonal lines. You always get jaggy. It's jagging a little bit, but it's not awful. And that's it. It's that simple. So what did I say at the start? So ignoring this line, that could have been done with, 2 lines? Because I could have combined all these 3 together. Some of you might say, well, hang on, if the angle's going to be the same, which hopefully it is, then why do we need to set the angle each time? You don't, really. So if I move that across and do start a frame and just set the angle at the start of the frame, let's try that. No, it works perfectly. And the problem is it goes on forever. Because it's just completely following that path. It doesn't care. what's happening when it reaches there. Under the one I had, when it was every 1 second, it was moving slightly past it and then slightly before it, slightly past it, slightly before it. So like the reason why I did it as I did, and just press Ctrl and Z to undo that, is if there's a slight problem, if there's a rounding error at the start when it calculates this, because this is done to, I think, 3 decimal places from memory. In fact, we can see it. So you can see that it's done to 3 decimal places, which is blooming precise. I mean, Clickteam's built-in directions only has, I don't know, was it 36, is it, directions? I have no idea. Can't actually remember now. So this is very, very precise, but it's still never going to be 100% perfect. And it's depending on the first 2 numbers. So if there's 2 digits there, then you get another decimal place. So this just basically just update it just in case it's slightly out. And if you look at it as it goes along, if you have a look at this number, it's changing slightly there. So it is making slight adjustments. Yeah, and so something that's really, really complicated, actually, if you have knowledge of working out the angle, which is this one, and then working out the X and the Y that you need for each little triangle, and that's basically what's happening here, is you just imagine these all right angle triangles, if you remember that from school, and we're just calculating the bit down and the bit across to create the angle that the A tan 2 creates. Alright, so heavy video today, but actually a really, really useful one. You'll find yourself in a position with a game, you'll be like, oh my goodness, how the heck do you do that? How do you do that? And this is it, and this has come time and time again. You want an enemy to shoot at you, like you want a smart enemy in a platformer to actually shoot a bullet towards you. Probably not like a home-seeking one, but just one that shoots at you initially, and then you've got to move out of the way. Well, this is how you do it. And you have the thing moving along. And Clickteam does have some stuff for that, like shoot at an object. I've always found it to be pretty bad for what I want to do. It seems to be trying to do something else each time. So having this in the back pocket is really, really useful. I'm going to shut up now. And tomorrow we're going to be integrating this into our game. So we're going to have the missiles created. We're not going to have the beautiful lines behind them yet, because that will be another video. But yeah, look forward to seeing you tomorrow. Thank you very much for watching this video. If you want to see more from us, please click subscribe. We release videos every single weekday at 7 PM UK time. Thank you.